Hello, I'm Laura Norman. There's a lot of people that have been working on this project with me, and some of them are listed as co-authors, and there's others that are listed at the end of my presentation. So some of these people are here with us. And so you've met Ron already, Trevor Hare, Lacher Austin, Miguel Villarreal, Floyd Gregg, and James Caligari are also working on this project with me. So the project that we're working on is at the Babocomari River, and that drains into the San Pedro, as you can see in this map, down and flows north towards the Tombstone Gauge. So that's part of the Sprinka. The Babo is a tributary of the San Pedro. It flows 22 miles from Sonoita to the San Pedro, contributing 6,000 acre-feet annually. It's typically a perennial stream, so that means that there's usually water flowing in it. It's got base flow during the winter of about 1 CFS, so not a lot of water during the winter, but in the monsoon season and the summer, we see a lot of flow coming through, depending on the rainstorms. So I wanted to point out the research that we're doing is really related to that perennial feature, in that the stream actually receives flow water from the water table. So when there's water occurring in the stream channel, that's because of base flow and contributions from the water table. So here's a map of the watershed, and again there's that Sprinka that I talked about earlier. The area that I have been modeling is surrounded in the blue outline. That's the Babocomari watershed. And Sierra Vista makes a big impact on the watershed with its urban areas. There's lots of runoff. There's also a lot of pumping. So there's a lot of people that live in that urban area that are drinking water or using water. And the Sonoita Plain region is outlined up there. You can see the research ranch boundary in the yellow polygon. So it's adjacent to the Babocomari. And this is an area that has been identified as having a cone of depression in the San Pedro, and I don't know a lot about that. That's not my area of research, but Laurel is a hydrologist specialist in this, and she'll be talking a little bit more about it. But I did want to point out that this is one of the reasons that we're doing the project there, is because of the drawdown and the cone of depression, which at one point there was a document that said the water actually, the river flowed backwards because of that cone of depression. So there's a serious water recharge is what we're working on. Okay, so the Babocomari Ranch is owned by the Brophy family. They purchased it in 1935. It's the largest land grant in Arizona. There's 28,000 acres, maybe more. I've seen different numbers. That they've got a huge commitment to conservation, stewardship, wildlife, and cattle. The TNC has worked on a conservation easement here. I'm not sure what the status of that is. I just saw that in the documentation in my literature review. But there's Frank and his dog, who you'll see if you went to the ranch. So the Walton Family Foundation's primary interest is preservation of base flow in the San Pedro River, and that the Sprinka is one of the key locations that they're interested in. So the Walton Family Foundation hired Borderlands Restoration to do some restoration because of their experience in gabions. So gabions are these rock structures that are put in the channel. They're wrapped in wire. They're dams. They can be used to detain or retain water. These are detention structures. The water slows down and then leaves. And these are pictures taken from San Bernardino that Ron referenced earlier, where there's been a lot of restoration work using gabion structures. But the Walton Family Foundation is interested in recharging the Babo, and so that's kind of a different angle than was used in San Bernardino, as they were interested in restoration. Here's a picture of some check dams that are similar to gabions, but they aren't wrapped in wire. This is a picture that was taken up in the Chiricahuas, and I've been working with Borderlands Restoration to do some analysis to get some quantitative numbers out of what the restoration structures are actually doing hydrology-wise. One of the papers that I started working on gabion structures was actually in Nogales, separate from all of this, looking at the reduction of peak flow. And so we were using gabions in the Nogales-Sonora area to reduce flooding problems. And we were able, the gabions were stopping these huge floods from coming through, and they put a big series of gabions all around the watershed at Nogales. And the gabions held strong, except for the extreme events. So that was successful. We also did some research looking at the Chiricahuas. And at that location that you see there is the Turkey Pen watershed, where we found a reduction or an increase in runoff in the long term. So it's a reduced peak flow, but an increase in surface water volume runoff. And that's because of the soils. And that's something that was brought up earlier in soil moisture retention. And the fact that when the precipitation hits the wet soils, it holds and slowly trickles down rather than is lost to other transmission factors like ET and some of the other things that were mentioned earlier. So an increase of 28% in volume in this paired watershed experiment. And we also have done some research looking at increases in habitat at the San Bernardino watershed, where we saw an increase in habitat at areas that have check dams or gabions versus those that don't. Especially exciting in that research was that the precipitation trends were going with the areas that did not have gabions, and so the gabions were able to defy the drought conditions. It's very exciting for hydrologists and arid lands to consider that. So on the Babocomari, we're trying to recharge the aquifer, so it's a different objective. But we're trying to use the same type of detention structures and seeing if those can increase recharge to the aquifer. And Ron and David and Trevor and Lacher all put together, this scheme where Laurel and I would be working with them to do some hydrology models and look at how different areas might be more appropriate for putting detention structures in. And so we're doing the hydrological model applications. There's been some satellite image analysis, and then of course using their expert opinion and going out into the field and identifying areas that need restoration or areas that would benefit just from a field eye from somebody that has some experience in doing that kind of work. Putting that all together and then going back and starting all over again and kind of going through this iterative and adaptive process to get the idea of the best place to put a structure for recharge. So we first looked at the hydrology water table, and these are some gauges that the GS maintains on the Babocomari. There's the Babocomari downstream, which has a regular kind of flow, and then upper Babocomari. And both are perennial. Right here it drips off. I don't know if that is true to the case or what happened there, but it's during the very dry spell, May through June. And so it might have dropped a low, but it's mostly perennial water. This is a water table that I created using the well data from ADWR to just try to look at where the water was existing when those wells were drilled. So the timing on the well data is subject to error, but we get an understanding of what it looks like under there. I also saw that vermilion flycatcher there. It was exciting for me. This is a satellite imagery analysis looking at the NDVI, and Ron talked about some analysis that he's been doing with NDVI. So that's the normalized difference vegetation index, and Natalie Wilson's poster over there uses NDVI to look at cienega growth. You might want to check that out. We were using it to look at areas that might be good candidates for restoration or good candidates for recharge because maybe they have wells or maybe they have access to the water table already, or maybe there's springs is what I meant. So we just went through and tried to identify some areas that have lighter in this area. In white is where the vegetation is. So this is like the Huachucos, and then it's, you can see the stream, the riparian is very light. There's also some areas that are really standing out. And maybe these would be good areas to try to reach the aquifer. So again, using the gabion structures to reach the aquifer to recharge rather than losing the transmission. Another idea that we had was to consider the satellite image analysis of faults and fractures. So looking at the geology of the watershed and assuming that if there's a fault or some kind of fracture, that it might be a conduit to the aquifer. So if there's a fault or fracture that crosses the stream channel, then we might assume that that would be a place where we might want to put a gradient. So this is Dravis's map from 1980, and he didn't really map the floodplains. And so Floyd Gray is working with us to go out and map the floodplain of the Babocomari. And this is a first draft. Don't tell him I showed you. We went out. We went out and did some field checking, but we need to field check the rest of this for publication. But the idea is to identify areas in the floodplain where there might be obvious faults that we can try to take advantage of and see if that too could reach the aquifer as a conduit. So that's something that we're working on right now. I ran this soil and water assessment tool. So it's called the SWOT model. It was developed by Phil's group over there at USDA. There's some inputs of precip and temperature and different soils to both. Here's an example of what that looks like. And really, like any model, the product of running this model is only as good as what I put into it. And so the land use data is pretty low resolution. It's 30-meter data. And the DEM, and then there's soils data, which I really want to go back into later and think about. As Dan mentioned, there's a higher resolution soils map for the research ranch I'd like to get my hands on and just kind of improve the resolution of that stuff so that we can see really what's happening in the watershed. But the inputs are the precipitation, and somebody's mentioned already the patchiness in Arizona. So we used the 4 different gauges, and those were distributed to generate estimates of rainfall through the year, and estimates of evapotranspiration were then created based on that and the vegetation, soils, runoff, and the Presley-Taylor method. No, I used the Penman-Monteith method. And so these are areas that might have high evapotranspiration, and these are this is an area that's relatively flat, like Russ was talking about earlier, and there's vegetation there. So the base of O'Donnell, hay, swamp, downstream from the ranch. It also creates estimates of surface runoff, and so this is a map of the surface runoff polygons for the watershed. And the darker areas are where there's higher runoff. So again, that's, think about the land cover, the DEM, what's the slope, what's the precipitation inputs there based on what gauges that we use, the weather stations, and how much rain might be coming off, based on that. So we identified O'Donnell and Laurel. The Huachucas, of course, had a lot of rain, a lot of runoff. It's very steep. And then around that Pacheco Springs area and Hay Canyon. Again, the sediment yield runs the estimates through SWOT, so that's using the runoff from the last slide that you saw. So instead of using precip, which most of the sediment yield models do, it uses the runoff that's already been predicted to make estimates of how much sediment might be moving through the watershed. So it's really more place-based and spatially accurate, although this is not accurate, and I really want to stress that these are qualitative results. The model has not been calibrated. So it's just trying to look at areas that would be higher erosion and areas that would be higher runoff. So O'Donnell, Pacheco, T4, and Atlas Cienega. So I want to keep that Pacheco area in your mind, and then Lyle and Slaughterhouse. The quantitative results, I compared that with the actual gauge data and see that there's not a lot of, the model over-predicted a lot. And so one of those things that is because the ET was not accurately represented for such a sunny place. It's a model that was developed for a regular kind of place, not a desert. And so that's something that I can change. But there's also some other factors. And so what we really wanted to do was try to increase recharge. And then Laurel can take over for a minute there. I'm going to come back now. There is the red dot. Okay.
Oh, hi. So yeah, we're going to shift gears and talk a little bit about groundwater now and how groundwater plays into this whole process of planning a restoration project designed to enhance recharge, which is then designed to protect and enhance base flows in a stream. So one thing we as groundwater hydrologists like to do is step back and try to understand the big picture of the system, because groundwater moves slowly. We think in long terms when we talk about groundwater. And this is a map, many of you have seen this before in other presentations I've given, but this is a map of the primary aquifer in the San Pedro Basin, extending all the way from Cananea, Mexico, up to the Tombstone Gauge. And we're sitting right in here today, in the Babocomari. And so here's the main stem. The Sierra Vista is right about here. Huachuca Mountains are here. And this is a projection, well, from 2000, projecting groundwater conditions out through 2050 and 2100. And so based on projected pumping rates, which were based on population growth estimates, where you see red, these are current cones of depression in the aquifer, meaning this is where the aquifer has lost water over time due to historic pumping. So today we have a cone of depression centered in the Sierra Vista, Fort Huachuca area, and there's a remnant one from a lot of historic pumping, agricultural pumping down in the Hereford, Palominas area. Over time, these cones of depression are slated to, well, this one especially is slated to increase along an axis parallel to the valley, along the west side of the San Pedro River. And what you'll note is that it's heading right under the Babocomari. And in the future, drawdowns are going to be quite pronounced under the central part of the Babocomari River. That's important for two reasons. One is, of course, it's going to impact flows in the Babocomari, which are already very small. So any little change is significant when you have a very small system. But it also impacts flows near this confluence area of the San Pedro within the Springa. So if we lose flows and contributions, even shallow groundwater that moves in the subsurface along the Babocomari, if that is lost, then we lose flows in the Springa. So two very significant systems here. So that explains why the Wall Foundation and others are very interested in trying to protect this area. My task was to take the existing groundwater model that USGS built for the San Pedro Basin back in 2006 and apply it to some study points, some areas where study plots have already been initiated in the Babocomari Ranch. So there have been some transects and some, I think, some actual rock dams built at these sites here that you see in green. So one is a Pacheco Springs site that Laura was pointing out. One is the Vaughn Canyon, Vaughn Canyon upstream of the headquarters, and then one is in Laurel Canyon downstream of the headquarters. This is the Babocomari Creek here and Turkey Creek tributary. And so then these blue dots are the model's representation of those drainages. I should tell you that this model is a very large-scale model. Okay, the grid in this model is based on cells of 250 meters by 250 meters. So basically 15-acre model cells. Everything within a 15-acre model cell is considered uniform. So obviously, if we're talking about making changes to very small tributaries, this model is not capable of characterizing that adequately. But what we wanted to do was just understand the lay of the land a little bit underneath the ground. So the lay of the groundwater in relationship to the creeks that we're interested in, and understand how the hydrology would react to changes imposed on it. So we looked at conditions that are in the groundwater model. This is just one of many maps that we looked at, but the groundwater model currently has values for horizontal conductivity. These are just various numbers that characterize the ease with which water can flow through the groundwater medium, so soils and rocks in the ground. Here's a number that's higher than here, for example. That means that water in the subsurface in this basin can flow more easily toward the river. Here it's more tight formation, maybe more clays, less fractures, so the conductivity is lower. There are various other maps, horizontal and vertical conductivity are also mapped in the model, but this is just an example of the kind of data that exists. This is a map showing groundwater levels. These contours represent water under the ground, not on the surface, and not surface elevations, but groundwater elevations. And then the colored squares here represent stream bed elevation. So what this helped me do was understand the relationship between the groundwater system and the surface water system. And what you can see here is that this 1,360 to 70 meter range corresponds only to the same elevation in the groundwater system right in this area of Laurel Canyon. This area here, the stream beds are all well above groundwater levels. So if you're going to do recharge up here, you've got a lot more ground to cover, literally. You've got a longer distance to get groundwater, to reach groundwater through the surface. Here, if you start in an area like this Laurel Canyon area, groundwater is already very shallow, so it's very easy to impose a change in groundwater level. Then we just looked at some artificial, some hypothetical recharge rates. Recharge rates are extremely low. I think I missed Russ's talk this morning, but I think he told you that there's essentially no recharge that happens in the uplands in this area. The precipitation is just far too low, groundwater is far too deep, and most everything evaporates. Natural recharge rates are built into this model. They're on the order of 0.001 foot per year. Okay, so the very tiny amount of water might get to the groundwater system. So what I did was I multiplied those values by, say, 1,000 to see how the system would respond to such a change. So instead of 0.001, we might get 1 whole foot of groundwater recharge in a system like the Pacheco Springs Steady area. Of course, I'm doing this over a very large area compared to what would really be done with the Gabian system. So it's inaccurate, but if we do this at repeated sites, we can see different kinds of responses. And one thing I'll point out here, I'm just flashing back again from Pacheco to Vaughn Canyon to the Laurel Canyon area. What you notice is this one, Vaughn Canyon, it's more receptive to the groundwater that's being fed into the system from the surface. But because groundwater levels are fairly deep there, there was no response in the Babocomari, and it didn't produce any surface flooding. In this area here, that green spot there, that's saying that the heads in the water table raised 85 feet. Of course, that's not true. There's not that much space in the ground. The model sort of is unrealistic because there's no outlet for the water that's recharged into the ground if there's no stream connected to the site. So this is one of the limitations of the model as it currently stands. The 85-foot number is unrealistic, but what it tells me is that there's a lot of water piling up because connectivities are quite low. It's not like you're just pouring a bucket of water in the sand and it's draining out immediately. It's more like pouring a bucket of water into some very dense clay, and it's kind of gradually soaking in. So here the groundwater table responds differently. It doesn't pile up as fast, but on the other hand, it's farther from the stream and it takes longer and more water to affect the stream. Here, groundwater piles up very fast. Again, an unrealistic head value because this system is not, you don't see any blue dots along Laurel Canyon in the model. There needs to be a stream connecting that system. There will be a stream if restoration creates surface flows, which this seems to indicate that it could. If you raise the water table slightly and suddenly you have water flowing across the stream, this model right now does not accommodate that. So what this tells me is we need to make modifications to the model, we need to refine the grid, and we need to add some stream structures. Here's an example of the cells of the model that are flooded. Each one of those little blue triangles represents a 15-acre parcel. So this is an incredible amount of flooding, right? But that's unrealistic. But what it tells us is there's a problem in the model. The model's unable to correctly simulate the conditions here. So this again was just a first cut to see how the different areas where they have some projects already underway might respond in comparison to each other. And this is just a little simulation of how the response from the Laurel Canyon recharge that was simulated. You can see about a mile or more of a small response in surface water flows just from groundwater moving through the system and discharging into the river. This does not account for surface flooding. So once we modify the model and allow for that head that's building up above the surface to flow out into the stream and connect into the Babocomari, we'll see these these values, instead of being very, very small values, 0.1 to 0.2 cubic feet per second, they'll be larger and it'll probably extend farther downriver. So the next steps for the modeling are to, as I said, refine the model grid. We're going to cut it into about a fourth of the resolution, or 4 times the resolution it has now, so maybe 4-acre cells instead of 15. Modify the stream structure to account for surface flooding and simulate actual realistic recharge values that we believe to be possible through the new restoration efforts.
Okay, so back to some of the other people that are working with us. There's Lacher and Trevor and David, and what we were trying to do is kind of a unique thing, stepping into this using all of these different expertises. And I was thinking that the visualization is a puzzle that really has never been cut before, and we're really taking these pieces and cutting them and trying to fit, you know, Lacher and Ron and David and Laurel and I together so that we can get the best combination of places based on all of our expert opinions. So they went out to the field and they identified areas like this at Pacheco, which wasn't really coming out in my model, but there's, you know, this huge gully there. And then speaking with John Milliken, who I think left, he was telling me that this gully is such a huge issue that it's actually a barrier for antelope, and that's a corridor they need. So there are other reasons to do some restoration at some of these sites, and we're trying to roll some of that information into our decision making. There's also some pre-existing dams. The CCC was out here since 1935 and put in a bunch of huge structures, some berms in Lyle and O'Donnell. And so we stepped away from some of those areas because of that pre-existing stuff. Here's a map describing what we propose to do. And you can see it in the Pacheco area, the Vaughn Canyon area. We've got some gabions in there and some berms, some talking about some nuke style berms. Then we also have one rock dams and media lunas. Those are things that were developed, I think, out of Van Clodier and Zedek's book. But here's a media luna is a spreader, so it's, you know, plastic kind of spreader meant to diffuse the flow. And the one rock dams, here's an explanation of those. So it's one rock high, like a chinchera is another word for one rock dam. Here's some of the dams that have been installed. So there's Trevor out in the field. That's over at Lyle. There's some at O'Donnell. So they started putting some of these in, and we're going to be putting in the avian structures as soon as the permits go through. So going back through and getting back up to the top. Now we've done all of that and mixing all together and hearing what those guys had to say and what she had to say, and they listened to what I had to say, and we went back and we redid it all over again. And so just trying to really make it so it's an iterative process. And how can the models predict how much sediment is going to be at those check dams? How big do they need to be? And how much peak flow might they expect at certain times? So we went out and did some GPS looking at the channels so that we could get a very good understanding of the geomorphology. Before and after, we actually tried to do some LiDAR, terrestrial LiDAR, but the second home there is so healthy and thick and high. But that's David Seibert standing out there, if you can see that man. To talk about Mickey and a grasshopper, so we did the GPS instead, and using some of the quantitative results. At Vaughn, if the precipitation is about 15 inches, then we might expect sediment yield at half a ton or 0.05 tons per acre per year. The peak flow might be a half a CFS, and these are over predictions, based on that calibration slide. So then we tried, okay, maybe we'll do proposed construction number 2, or maybe proposed construction number 3. And then we had a fire in Vaughn, and so that we went back again, and now trying to figure out, what are the implications of the fire hydrologically, and how is that going to impact how much sediment might be expected at the different check dams, and what would be useful at those locations. So there's a fire map that we're considering that will also be part of the calibration period, as putting those fires into the model will help to better make estimates of what's happening. I also found Ron Tiller and Dan Robinette have been doing a lot of great surveys, vegetation, geomorphology. I'm hoping to capitalize on their good efforts and use some of that information for before and after studies so we can continue on with their research there. James Caligari is planning to do some electroconductivity studies above and below the gabions, above and below the burns, above and below the cienega. And so that will be very interesting to see if that study can identify the water proximity to the table. And we also have some drones planned to fly the riparian areas, and so that's really exciting. We can get a very high-resolution DEM from those drones. There's aerial photos that can be paired to get a DTM, very high resolution, 1 centimeter. And there's also the potential to do some vegetation index analysis with the color imagery and near infrared. So we're going to be doing that in October, November, and Linda said maybe it'd be okay if we came up here on the research ranch and flew up here too. So we might be able to fly that in. And I think David's going to talk a little bit now about Borderlands. So.
Do we have time?
I think
You guys have questions for those guys first? Go ahead.
Oh, I just need 5 minutes.
5 minutes?
Yeah, come on.
You want to take questions now? Okay, whatever. Okay. Okay, let's just briefly, yeah. Hi, thank you. I'm David Seibert. I'm the director of Borderlands Restoration. I've been involved in ecological restoration work for about 20 years in various capacities, working on wetlands and sacred sites in northern Arizona. Most recently, I was proud to have worked with the Altar Valley Conservation Alliance and Charlie and Mary Miller over there from the Elkhorn Ranch. You heard a little bit about that earlier. I was there for about 5 years and was able to, I think, create and try to maintain a really large restoration network and get a lot of good practical work done on the ground at the wildlife refuge and then on private ranches. And I think one of the things I'm most proud of is doing some of this boundary work. Right? A lot of the different components, pieces of this kind of work you've seen already today, as far as concerns about mesquite and erosion control, boundaries, insects, birds, critters, bipeds even, or in the mix, right? What do they care about and why, and how does that inflect landscapes and what we do to them? So right about the time I was finishing up a grant, a fire planning grant, from which I learned a great deal from Larry Humphrey and Dan Robinette, as far as training on doing prescribed fires and interacting with ranchers and getting their concerns mixed into it. We were winding down on that one, and I was recruited by Ron Pulliam and Gary Nabhan, who said you ought to go check out what's going on in Patagonia. These guys are trying to build a new kind of organization that might have something to offer the region. So I transitioned over to Patagonia about 2.5 years ago as a conservation director, with no designs on becoming a director by any means, but here I am. And Ron is our visionary who started this whole thing off. He's going to be probably angry at me for citing him as one of the most famous ecologists in the history of the U.S., with probably the top cited paper in the history of the U.S., and instrumental in setting up the Eugene Odom School of Ecology in Georgia, very famous unit. So Ron's our visionary. We wanted to kick this off, and I wanted to have a hand in starting it. I brought some of my skills and some of the networks over. But I'm trained in anthropology and the humanities mainly, and as I said, an ecological practitioner on the side. So what Ron's vision was is to create a restoration economy, and you could see a lot more details on our website, borderlandsrestoration.org. What Ron's vision, and then the rest of our vision, you know, Joan Valera Austin and others who are on our board, we'd like to work really, really hard on ecological processes such as hydrology and soils, work on vegetation, growing out vegetation, doing research on vegetation, and trying to find out what kinds of vegetation are missing from the landscape, missing from the nectar landscape in particular, the plants that have dropped out of a system because of degradation, drought, climate change, that we think we can get back in there. So the restoration economy part has a very strong community base, and we think we want our organization, Borderlands Restoration L3C, to be kind of community driven. We want it to be owned by the community, and we want to create jobs, create skills around this kind of work. We feel very, very strongly about that. And a number of you, just even today, have asked about our model. It's an L3C, it's a limited profit company. It's actually a company that's in business. We're the first limited profit company in the state of Arizona. And in order to get that designation, which comes with some of the benefits of a nonprofit, which we also have going side by side, we need to direct our energies towards a social good. And the highlight of that is that we can receive program-related investments from people who believe in what we're doing and who can expect maybe a 2 or 3% return on their investment. That's what kicked us off. They might get 0 sometimes, but they're probably not going to get a spike of 12 or 15%, right? It's not tied to the stock market, it's tied to the land. It's tied to what people want and what can get done, and trying to coordinate interests and see where those interests overlap so that we can put our energies in the best place in the same way that we would if we're going to wonder about whether or not to do mesquite removal. So we are in the business of doing restoration, of consulting, doing bioassessments, research, literally going out and collecting seeds and plant material, growing them out in 2 new greenhouses that we have built on Native Seed Search property, one of our primary partners. And one of the agencies that helped us kick this off is BLM, because there's a crisis in the United States right now regarding our seed stores. Apparently our seed banks are at a historic low in the history of the U.S. and BLM is worried about that, and anyone who's worried about what we're worried about should be very worried about that too. So we're being supported to experiment with seeds and try to get in cultivation some of the native species that are very important to wildlife, as you know. Get them into commercial production. We want to lift up others in other communities, help them build greenhouses, help them direct their energies towards this, whether they're heavy equipment operators or biologists, all across the board, age 5 to 90. I like to describe a lot of our projects like the Babocomari as sort of creating a canvas or a platform that other people can attach onto, whether they're university researchers. We serve the interests of the landowner, try to keep ranchers ranching on the land and holding the landscape, and then try to add added value to these things in the way that Laura and Laurel have just described. In fact, we have a pretty good opportunity to have Tom Minkley come down and do some subsurface high-tech modeling of cienagas that could contribute very, very strongly to the Walton work that they just described for only about $4,000 more. So I'm going to turn to the Walton Family Foundation and suggest that we change a line item on our current grant, or maybe get another small grant to add this value and just make a good project even better. So from Borderlands Restoration perspective, we kind of want to be an organizing node and a coordination node that opens up possibilities to cover a number of different interests all at the same time. I'm really proud to have the grant that we have with BLM that just got renewed for us to learn and grow. We have another cooperative agreement that we're kind of breaking some new ground with the Forest Service so that we can collect material on Forest Service lands, under permits and everything, of course. But we're helping the Forest Service achieve their goals while we're achieving ours. In the meantime, we're training people in the community about how to do this work, opening doors for high school students to think about alternative careers. Similar kind of efforts with the National Park Service. Steve Buckley's back there, one of our botanists who's just been tireless in trying to make these connections and build bridges that didn't exist before, so that we can actually get native or National Park Service seed, grow it out, and return that seed back to their restoration project they have planned, but also be ready to respond really nimbly, really quickly to fire effects, for example, to be able to have material on hand that we can offer up to go back into these landscapes in a way that's got a really strong research component, but also a really strong people component, to try to help rebuild communities and connect people in ways that maybe they've had trouble doing. And that's important in Santa Cruz and Cochise counties, which are two of the most impoverished in the United States. So, and we're very proud to be working along the U.S.-Mexico border too, I think I can say, where there are a few issues in the region. So, thank you very much. Yeah, appreciate it.